Okay, let's go over this warm-up on 4.3 and 4.4. So let's go over the answers. This won't take long, but it is important that you understand what we've been doing so far in these two sections. So we learned a new tech for dividing. So we're dividing, and we can use synthetic division for this problem. We're dividing by n plus 5, so we make a half box. We put it 0 on the outside. So what makes this 0 is a -5. We line up all the coefficients. It's a cubic polynomial, so we're going to need 4 numbers inside, and we have all of them. We have the 1, we have the 15 for the square term, a 41, and a -36. Okay, so that's the setup for synthetic division. You always bring down this first number, and then we multiply. -5 times 1 is -5. We then add. We multiply, we add, we multiply, and then we get our remainder. So in this case, we get a remainder of 9. Okay, so now we don't want to stop here. We actually want to write the quotient.
Quick question.
So 9 is our remainder, -9 is a constant, 10 is the n term, in this case I used an n, and then 1 is the square term. So we have 1n squared, 1 less than what we started with, and then plus 10n minus 9 plus my remainder over my divisor. And there's the quotient. Okay, easy. So then here in 4.4 we learned several techniques of factoring polynomials. If you see 4 terms, and I don't tell you anything else, I don't give you one of the factors, you will be able to split it down the middle. Okay, so you'll split it down the middle and factor out the GCF on the left side. So in this case, it's simply an r squared. So I'm going to have a 3r minus 5 inside my parentheses, which means for this to work, I must have, and I just made a mistake, I never put the 3 inside the parentheses, so I need to see 3r minus 5 inside the parentheses, so that tells me I need a -9 on the outside. -9 times 3 is -27r, -9 times -5 is the 45. So then we take the pieces on the outside, that makes up one of the factors, and then what's in parentheses is your other factors. And then you need to recognize we're not done. Since we have an r squared, or n, why did I all of a sudden, yeah, no, it is an r. R squared minus 9 is the difference of perfect squares. I break that up as r plus 3, r minus 3, and then we have our 3r minus 5. That is fully factored. We are finished. Okay? So then number 3, this is simply just a quartic trinomial. The middle term's x squared. So you just do 2 sets of parentheses. It's x squared, x squared. It's a positive 100, but I need to come up with ways of getting 100 to add up to a -29. So I know it's minus minus, and my brain already told me it's a 25 and a 4. Okay? But once again, special cases. Now, if this wasn't a perfect square, we would be done, but we have 2 perfect squares here. We have to break up x squared minus 25 is x plus 5, and then x minus 5, x plus 2, the square root of 4 is 2, and x minus 2. Now, we're fully factored. Okay? This last one, where we have to be able to find k. We kind of have to work backwards to do this. So we're dividing by x plus 2. We can use a half box. And we're told we must get a remainder of 0. Okay, so we do know that we get a remainder of 0 when we divide by x plus 2. So I put a -2 on the outside. We have a 1. We don't know the k. We have a -9. And we have a positive 2. Okay, so I know I can put a -2 there. And we work forwards to this point. Can't go on because I don't know what k is, but we'll figure it out. And then we have to kind of work backwards to know, okay, if this has to be a -2, this has to be a 1, okay? Because negative 2 times 1 is negative 2. And then what you need to realize then is this has to be a 10, okay? Which then forces this to be a negative 5. Okay, so now we have enough information to figure out what k is. K, and then if you add a negative 2, we know it has to be a negative 5. So if you solve this, you're going to see that k has to be a negative 3. So if you have a negative 3 here, everything's going to work. You bring down the 1, you multiply, you get negative 2. If this is a negative 3, you'll get your negative 5 then here. You'll multiply, you'll get a 10. You'll add, you'll get a 1. Negative 2 times 1 is negative 2. And then that forces you to get a remainder of 0. And that's what we are looking for. We're trying to find the value of k that makes the problem come out to a remainder of 0. Okay, so that was a quick 5-minute warm-up. Hopefully you understand everything so far in section 4.3, or excuse me, 4.4, and, or excuse me, 4.3 and 4.4. Take care. Thanks for watching.